Hello and welcome to this series on best practices. In this video, we're going to talk about best practices specifically inside of Unity. We'll do a brief introduction, talk about Unity, and then jump into the best practices specific for Unity, looking at a case study and finally doing a demo. For more information on my thoughts for best practices in software and in games, check out the other videos in this series linked above and also in the description below. My name's Sam. I'm a game developer with over 20 years of experience, and I'm Unity certified. I've developed Unity games over the last decade or so and shipped for all sorts of different platforms. Along the way, learning a lot about best practices. I've shipped titles for mobile, PC, Xbox, Steam, and more, and also taught at universities and created online courses around game development, best practices, programming, and the specifics of the Unity game engine. And speaking of that, let's jump in and do a quick overview of Unity itself. Taking a look at the list here, a game needs to have UI, input, audio, rendering graphics out onto the screen, as well as the animation for the characters and the world, and then of course, scripting or coding your game with C#. Unity offers us those essentials and much, much more in the built-in features, and has optional services as well, which connect your game to backend, so that you can do things like multiplayer gaming, generating analytics, running ads inside your games, monetizing it, things like that. Now, Unity can be used across all the stages of the software development creation lifecycle, but we see most of it being used in the development phase here. That's probably the largest single step as far as where you and your team will spend your time. That's coding it, bringing together all the concepts, the art assets, etc. And then finally, you can do your testing in Unity and of course, deploy to your platform of choice from Unity itself. And when we're developing with Unity, what do we mean by best practices? Well, here's an overview. For more about the best practices in software that we see here, and also applied to games before we get to Unity as a specific game engine, check out the rest of the series, the links above, and also in the description below. To recap, you've got principles, standards, patterns, frameworks, architectures, and more. Best practices are about creating the developer quality of life experiences that lead to the best quality product in your code base and your project's organization. Some of the benefits here are that it makes a better quality of life for the team as you get into the creation of the 100th feature inside of a game, where if you don't follow good, solid principles from the beginning, you may find yourself limited later in the game about how quickly you can make a change to your code base and what the cost or effect of making that change is. Within principles, we've got lots of different acronyms, including don't repeat yourself or dry, keep it simple, stupid, or KISS, and the solid principles. Within standards, there's all sorts of things to talk about, including designing the project structure so that the folders and the files are organized in a way that is more maintainable and leads to that quality of life I mentioned. Also establishing coding standards so that all the C# that you and your team create is readable and consistent across all of your code base so that it's easier for people to join the team. And when they depart the team, their knowledge is properly documented and put inside the code base as well. And having a purposeful process there as well. Then when you're sitting down to code your solutions, you've got all sorts of design patterns. We can think of design patterns being built on top of the design principles, and they include different types of solutions for creating your objects, the behavior between your objects, and how you structure your objects together. Then taking that information and putting something on top of it, kind of the next logical iteration, is building frameworks, which are subsystems of your game or your code base that allow for even larger complexity. So having your communication through some central event bus, having your enemy logic through some sort of state machine, maybe having NPCs use a behavior tree. There's lots of different things you can do there. You can think of frameworks like groups of patterns and patterns like groups of principles. Everything's building. And finally, an ultimate step here is to have an architecture, something that most of your game or your entire game fits within as far as a logical structure. And having an architecture, if you choose to take an off-the-shelf solution, it can have ramifications to your project structure, your coding standards, the process you use to adding new features, as well as has implicit principles and patterns and even frameworks built into it. So over the course of this list, you can see starting with simpler concepts and building up to something quite big in the form of an architecture. Now, when we look specifically at Unity, some of the things that I think are important is using version control so that your project is easy to back up, share with others, and version so that you can always step back if their team makes any mistakes. A very popular option is to use Git, and a popular form of that is github.com. But you can use lots of different ones, any one that you want to use. Within Unity, I recommend working with the latest LTS version of Unity. So Unity always has some older versions of the Unity editor, the current version that is public, and then some beta future versions that are coming. You want to be in one of the current versions, specifically marked LTS. That's a reference point that the Unity team is going to continue long-term support for that Unity version. It can be very fun to play around with the newest features, but if you're on a serious project that has a lot of risks and investment in it, you may not want to jump any further into the future using any betas yet. You want to wait for those to reach the LTS version. Then I recommend in the settings to use IL2 CPP, which is one of the settings under the hood that makes your game run more efficiently on most all the platforms you target. And there's a lesser known option within the Unity project settings called Enter Play Mode Options. And by checking this on, you get much quicker compile times. And it's something worth checking out or Googling. I'll put a link below about it as well. But when you choose to do that option, the reason it's not the default is because your code needs to have a bit of particular setup in order to run stable. So when you're cleaning up the way that your static variables, for instance, that's one example, how they operate, you need to manually clean them up. And then moving on to structure, Unity has had a convention called asset bundles that has now been replaced by addressables, as listed here in the screenshot. Addressables are a way to take your one big project and instead of deploying a 100 meg game to your users, you can divide it up into smaller chunks. That helps the delivery of that be more dependable to your user base and also allows you to replace certain megabytes within that project without requiring the entire thing to download. There's also a lot of workflow benefits to using it as well, as far as being able to optimize the RAM consumption inside of your game. And like many best practices, it's good to start your project with it in mind because adding it later in the game can be a challenge. So if your project could benefit from some of those things, it's good to think about addressables up front. Also, it's not a best practice that I can easily prescribe with just a few words here, but being very conscious of this balance you have between what is a scene in your game and what is a prefab. While two different concepts there, they can be used to solve some similar challenges about dividing up your code base and spreading it across the user experience. So being purposeful with how you design scenes and prefabs. It's possible to create a game, for example, that it all sits within one scene. The end users aren't necessarily going to know the difference, but perhaps that complicates your development. So I generally approach things by having your game divided up into 4 or 5 different scenes, and we'll see that in one of the examples later. Then using purposeful scriptable objects in your project, they are an alternative to the more common mono behavior, and you can think of them being some kind of a editor time storage that you can bring in and use different data types in a nice way at your runtime. So if you're not already exploring scriptable objects in Unity, it's a fantastic tool. Then as far as the different packages that you can bring in optionally into your project, I recommend starting from the beginning of your project with async await libraries, with a localization library, using the Unity's official input system versus their older input manager, and using Unity's UI toolkit instead of the older Unity UI. Again, these choices could be made anywhere during development, but the earlier you do, you're going to be able to reap those benefits and have the functionality that each of these brings spread more evenly across your code base. Now with async await, if you're using Unity before Unity 6, you need to bring in an external library. One popular one is called Unitask. With Unity 6 and beyond, Unity has an official package that you can bring in, and generally I recommend using Unity's official solutions if they meet your needs, and it's pretty good there. Localization as well, there's lots of third parties, but Unity has their own, and I already mentioned those other two. Now, finally, from a workflow standpoint, some of the things that many teams consider optional, or perhaps it's not their preference, I think are essential. And here in workflow, I have a couple check marks that I always want to include in my projects. One of them is to make any scene loadable directly from the editor. So let's imagine you have a menu scene, an in-game scene, and then an outro scene or a high score table or something, just to give an example of a third scene. In development, many teams will require that first menu scene to always be run first, and that's where they'll initialize their system. Whatever bootstrapping or initialization logic that the game requires exists only in that scene, or only in a dedicated bootstrap scene. Thus, when you're developing on the game, you always need to leave the current scene you're working in and go run the scene playing in the Unity editor from some other scene. Now, that's probably easier to set up as far as getting the job done. However, it's much more complicated to work within such a system. You're always needing to go back and replay the user experience from that beginning menu scene, or you end up adding some cheat buttons or temporary shortcuts that help you as a developer skip certain sections of the user experience. The alternative that I recommend is having any of that bootstrap logic live in any scene, so that no matter what scene you start with, the game loads faithfully with some nice fallbacks. It is not an easy thing to add, but it is really, really worth it. So if you're working on your own project, even as an individual, you could get great efficiency boosts if you take the time to set that up in the beginning. Then I also like to have the project automatically build itself. So within Unity, you can manually go to a window to build it for the platform you're working on. So let's say, for sake of argument, I'm creating a game and it's going to be played on Android phones. Maybe once a day or once a week, I will actually build it to device and play it on that mobile device, doing a manual build process. And that helps you work mostly in the Unity editor, which is easy and fast, and periodically be checking it on that actual target device to make sure things like input or accelerometer or the screen layout all look good on that target device. An alternative to manually doing it is to have this build process be automatic. Now, there's lots of ways to set this up, but imagine one scenario where any time that you or one of your team members commits to the code base, let's say on github.com, it will automatically kick off a build, automatically email some or all of your team members a link, and they can click on it and play it immediately on their phone. This means that you're getting your build process done much more rapidly and much more easily so that you're able to spot errors. It also is less time consuming once you get it set up, that you're able to get these benefits without manually building or having someone on your team doing all that. And lastly, especially with the automated build setup, having unit tests automated so that they run is a very helpful way to make sure that your code is maintainable and scalable. So a project set up with those automated tests has those tests run as part of that build process and make sure that your code is maintainable and dependable. Now, if some or all of those things sound like they're interesting to you and you want to learn more, you can check out a lot more info that I have available at the URL listed here. In this best practices package, we've got articles about best practices, such as how to create coding standards, why that they're important for your team to have, setting up a good Unity structure, also being able to have a lot of these different features demonstrated for you inside of code samples. So you can take a look at those, and there's tips as well in there for Unity development. And included in that is coding standards. Now, the short answer here is that it's not particularly important what coding standards you choose. It doesn't have to be what my standards are, which is the ones shown here. These are heavily influenced by the .NET standards provided by Microsoft, but tweaked a little bit for Unity's sake. It's not important that you use my exact standards, but I do think it's a great practice to at least talk as a group on your team what those standards could be, create a template, and then have everybody adopt that in a consistent way, or at least recognizing where consistency is important and where consistency is not. But this is the standard that I like. And I like to have things organized vertically in a certain order so the team knows where to look, and having some of the naming structures, which are, again, general.NET Microsoft standards, used here. So a variable begins with a capital letter if it's public and an underscore if it's private. And there's a lot more you can learn about that by looking at that link that I mentioned to see more about coding standards. And also included, shown here on the screen, is an example of the project template that I provide specifically for Unity. So if you're starting a brand new project and you just want to have a nice folder structure that speaks to some of these best practices, we've got a great project that you can download through that link. And taking a look at the project window here, here's some of the starter folders that are provided for you. I'll go through a couple of the highlights here. So a third-party folder is a great spot to put any third-party libraries so that they don't get too messed up, makes them easier to notice which are brought in as third-party libraries for the asset store, for example, or things that you find on Git, or that each team member brings from past projects. Also makes them easier to update by having them centralized there. I like to have the art folder, which has some subfolders within that are not shown here. I like to have that be its own area here so that teams know exactly where to contribute as an artist. So this might contain the sprites, images, animations for characters, models, 2D sprite sheets, and stuff like that, all included. Then having documentation, be a first-class citizen there, invites your team to have README files or links to online documentation, images, diagrams, etc. Then some Unity things like prefabs, scenes, and resources are included here. Then inside the scripts area, I do two things. I break up the code into editor, runtime, and test folders. And then in each of those, I have an assembly definition, which is Unity's solution to have unique code areas, something like a DLL in the .NET world. Then in the settings, it's kind of my catch-all for a lot of the different scriptable objects that Unity requires as part of their setup. So things like physics and presets, your URP render settings or HDRP render settings, other types of resources that you might have in there. And then UI Toolkit particularly has some complexity to the number of scriptable objects and the UXML files that are inside. So I put that down there. Again, it's not so important you use exactly this, although I do like these standards, but coming up with some form of those standards that work for you and having it be used on your current project so you get the benefits, and reusing it across multiple projects in your portfolio will also help orientation. When you pop back into an existing project after some time, you'll know where to find things. So all that and more is available at the best practices link. Take a look, download those projects, read the articles, check it out. Let me know what you think in the comments below. Now, wrapping up what we took a look at here in this video, we saw a quick intro to Unity as a platform and then also some of the best practices. I hinted at some of the ones that are best practices for software in general. You can watch the videos in the series earlier than this one for more information about that. And then we talked about the best practices specifically in Unity and a bit about that link with some more resources for you. Now, there's a demo that I want to take a look at, and I'll do that in the next video in the series, so stay tuned to see a Unity demo that exemplifies everything that we talked about here. Thanks for following along with me. I'm available for remote contract hire, doing work within best practices, and also bringing my best practices along to do any development work, on-site games, and non-game applications. Thanks much.